All right, when we get to the problems 39 through 51 odd in the section 6.5, there's a lot of, let's do a simple one first. Okay, let's start with, let me start with 43. All right, we can go back and forth between radicals and exponential exponents, okay? And the reason that we like the fractional exponential exponents, oh my gosh. We can go back and forth between radicals and fractional exponents. Let's try that, okay? And the reason we do that is sometimes we have more rules that, something that works better in one case over the other. There are times we prefer radicals. What they're asking us to do here is change them over because we're getting ready to study exponential equations. And so in that case, it's going to be easier for us to deal with fractional exponents. So if we want to change this over, it says simplify the expressions, transform them from radicals to exponential form, leave the answer in exact form as a radical or a power, not as a decimal approximation. And it says you can check your answers using a calculator. Okay. So what they wanted us to do, first of all, look at the cube root of 128. They want us to rewrite that with a fractional exponent. That's 128 to the 1/3. Okay? Now, we've got the square root of 32. We can rewrite that as 32 to the 1/2 power. Now, you might think we could just start multiplying away, but remember, our rules of exponents have to apply here. So is there something we can do? Well, yeah, there actually is. If you look at it, we can rewrite both of these as powers of 2. Let's kind of look. Let's kind of start with someplace. 2 to the 5th is 32. I could build it up from there, but you need to at least know that 2 to the 5th is 32, 2 to the 4th is 16, and on down. Everything below that you should know. Let's kind of keep going with this. Let's multiply 32 by 2. What do we get? We get 64. What's 2 to the 7th? 2 to the 7th is 64 times 2, which would be 128. Aha, that's what we have right here, isn't it? Okay, so 2 to the 7th is 28. So what I'm going to do is I want to get both of these in the same base, is I want to rewrite this as 2 to the 7th raised to the 1/3 power. Okay, so I've got this as a base of 2. The reason I did that is, do you also notice that when I have my exponents up here that 32 could be rewritten as 2 to the 5th? If we can rewrite these as the same bases, then we can actually combine them in a way using these these radicals, okay? Using these fractional exponents. Sorry. All right, so let's rewrite. Let's go ahead and simplify these. 2 to the 7th raised to the 1/3 power would be 2 to the 7/3 power. Now, if we're going to multiply, 2 to the 5th to the 1/2 power would be 2 to the 5/2 power. I really didn't need those parentheses there. I don't know why I just wrote that, but anyway, I did. All right, now we've got the same base, and we're multiplying with the same base. So the exponential rules say that we can write the base, and we can add the exponent 7/3 plus 5/2. Well, we're going to have to get a common denominator to add those exponents. So let's get a common denominator of 6. So we'll multiply 7 over thirds times 2 over 2, and we'll get 14 over 6. And we'll multiply 5/2 by 3 over 3 to get a common denominator of 6. And that would give us 15 over 6. It's hard to read that 3 over 3, but that's what that was. So 15 over 6. So now if we can add our exponents, because we have a common denominator, that's going to be, remember when we add fractions, keep the denominator the same, we keep the 6, but we add across the top, that's going to be 2 and 29 over 6. This is why we sometimes take these and rewrite them. Now, I hope you're getting to the point where fractions don't freak you out, but I know they do, some of you. So I'm going to go ahead and do this one, even though it may not be one of the harder problems here, honestly. 2 to the 3.1 divided by 2 to the 0.7. Okay, first of all, if we look inside of there, they're messing with us a little bit. They could have written this as 2 to the 3.1 over 2 to the 0.7. And I haven't really rewritten this as a fractional exponent yet. I'm going to wait till I'm going to kind of keep simplifying in the inside first, just so we don't have such a confusing thing. Do you remember the rule is if you've got exponents on the same base, you subtract them. So all we're going to do is say 3.1 minus 0 0.7, which would be the cube root of, let's see, that would be 2, that would be, it's like 31 minus 7 would be 24, so this would be 2.4. Okay, so if I've got the cube root of this, that's just going to be 2 to the 2.4, and instead of writing the cube root, we're going to raise it to the 1/3 power. Well, look how nicely this simplifies. Since we have a power to a power, the rule is that we multiply these two numbers here. So 2.4 times 1/3 would be the same thing as 2.4 divided by 3, which would be 0.8. So we'd have 2 to the 0.8 power. Now, the instructions said do not write this as a decimal. You never want to. You want an exact answer. So don't put this in your calculator. You could check it. You could use your calculator to put this in and see what it is as a decimal, and type this in and see what it is as a decimal and see if they're equal. That would be checking, but this is the answer they want you to write. Let's look at 51, and then again, if after 51, you could go back and do 49 pretty easily. Some of these things look bad, but if you don't just go, I give up, and you start and you think about what PEMDAS tells you to, you can figure these out on your own. You really don't need me to show you so much of this as you might think. All right, so remember PEMDAS, in order of operations, if we've got some kind of grouping symbol, we always start on the inside. So I've got the square root of the cube root of 36. The inside part is this cube root of 36. So let's rewrite it as 36 to the 1/3 power. Okay, but then on the outside of that, we still have a square root. So that would be 36 to the 1/3 power. I'm just copying down the inside of it, but that whole thing is raised to the 1/2 power. So now I've got a base of 36, and I have a power to a power, so if I multiply those, 1/3 times 1/2 is actually a 1/6. This is the same thing as 36 to the 1/6 power, which would be a lot easier to work with if you were messing around with some algebra instead of these nested radicals here. Let's go back up and look at freak a lot of people out because you think, oh, there's so much stuff under there. But really, you know, it's not as bad, again, as you might think. Let's look at it. For 47, they're saying you got the fifth root of 10 to the 4.4 times 10 to the negative 6.3 divided by 10 to the negative 8.1. So let's just kind of start on the inside. I mean, we know that all this stuff eventually is going to be raised to the 1/5 power, but before we do that, let's just keep simplifying. All right, the thing that's going to help us here is we have the same base, 10, 10, 10. So let's just kind of go left to right. When we multiply these two together, do you remember that what we do is we write the base of 10 down, and then we're going to add those exponents, so it's 4.4. That's why you got to know those exponent rules, plus negative 6.3. And then I'm just going to copy down this divided by 10 to the negative 8.1. I'm just going to kind of keep up with it right now, okay? I could do a lot of things at one time. I'm trying to do one step at a time for those of you who need it. Now, 4.4 minus plus negative 6.3. If you're worried that you're going to get that wrong, you know, with the negatives, I sometimes do. I'm actually using my calculator right now. That's 10 to the negative 1.9 power. But then, that's a negative, and it's divided by 10 to the negative 8.1 power. So let's see what that looks like. That's the fifth root of 10 to the negative 1.9 over 10, remember dividing is just a fraction bar, negative 8.1. Well, when you have a fraction bar like that, you remember you can just subtract your exponents. Division, what do we do when we're dividing with the same base? We subtract the exponents. So that's 10 to the negative 1.9 minus 8.1. Oh, that's going to be good, because that's going to turn out to be a positive. A minus is going to become pluses, aren't they? Okay, so really what we're looking at, negative 1.9 plus 8.1, is the same thing as 8.1 minus 1.9. And again, I'm using my calculator just because I'm a little afraid that I'm going to make a stupid mistake. And so you might want to do this too. Again, we don't want decimals, but we could use these for our exponents. This is the fifth root of 10 to the 6.2 power when we subtract these two, just using the exponent rules. Okay, so I've got the fifth root of 10 to the 6.2 power. So now all I have to do is say that's 10 to the 6.2. Taking the fifth root of something is the same thing as raising it to the 1/5 power. So once I do that, I see that I have a power to a power. That exponent rule tells me to multiply. So now I could change 6.2 into an improper fraction and multiply it by 5, or I could use my calculator to do that, and that's what I did. 6.2 times 1/5 is the same thing as 6.2 divided by 5, and I put the wrong thing in my calculator. We get 1.24. This is 10 to the 1.24 power. And we're done. Okay, so 53 to 59. They're trying to get you they're actually, this is a discovery problem. They're trying to get you to think about what you just did, and they're trying to move you along into what you're going to do in some sections coming after this. This is actually getting into how we're going to solve some exponential problems. 64 to the x power is equal to 4. What could I do? I've got a 4 here. How about 64? Couldn't I rewrite 64? Just going to leave everything else the same. I'm going to rewrite 64 as 4 cubed. Okay? Oh, there's a power to a power. This would become 4 to the 3x is equal to 4. Does this 4 on the right, does this one have an exponent on it? Doesn't it have an invisible 1? So if I want to solve this, what I could do is say, if these two things are equal, if you got the same base, that means the two exponents must be equal. So you could come over to the side and say, well, 3x is equal to 1, because the exponents must be equal, and you could just solve for x. Divide both sides by 3, x equal a third. Kind of tricky, isn't it? I'm probably going to run out of time, but I'm going to try to do at least one more of these. 49 to the x is equal to 343. Here's one thing I know about those two numbers. They're both powers of 7. I knew that 49 was 7 squared. So I just checked, and guess what? 7 times 7 times 7, 7 to the third is actually 343. So sometimes with these problems, if you can figure out one base, you can go check and find out, oh yeah, the other one's also a power of 7. So now our exponent rules say a power to a power, we would multiply. We would get 7 to the 2x power is equal to 7 cubed. If these two quantities are equal, since they have the same base of 7, that must mean these two exponents have to be equal. So we come off to the side and say, well, let's see what they would be if they were equal. We'll solve for x. So if I want to get x by itself, I divide by 2. Oh, I get x equals 3/2. That's my answer right there.